In 1892, Alexander Gleason released his new standard map of the world as it is, which remains to this day one of the most accurate flat Earth maps ever created. He had hopes it would completely replace globes and Mercator maps the world over, but unfortunately his map's influence was short-lived. The next year, in 1893, Gleason published his flat Earth tome entitled Is the Bible from Heaven? Is the Earth a Globe? Does Modern Science and the Bible Agree? Which gave many flat Earth proofs and also explained his wonderful map.
Welcome, everyone. So let's talk about this triangle at the top of the Gleason's map. Everybody says it's a Masonic triangle. Well, it is an isosceles triangle. I'm not so sure it's Masonic. By looking at it, if you notice all the 3 points, the base of the triangle is at a very specific position of the 45-degree south latitude. Now, what's interesting is that if you flip it upside down, it points exactly to the North Pole. Now, this is very important because by doing that, it actually marks the position of the base as being measurable. So in other words, the distance from the base to the top of the sun emblem that's on the map is equal to the distance between the base of the triangle and the North Pole. And by doing that, we can calculate the distance because longitudinal lines are equidistant on a circle map and as azimuthal equidistant map, and we can calculate the distance because every degree is 60 nautical miles. So let's look at what they've told us so far. The moon is 238,000 miles away from the Earth. There's 29.5 average moon days. That's a synodic. I'm assuming that's on a yearly basis. Couldn't really find that on Wikipedia. The sun is 93 million miles away, and the distance to the sun versus the moon is 390 times, but they always say it's 400 times further away than the moon is to the Earth. So now we look at what we know so far, what we have discovered. We know from the North Pole to the equator is 90 degrees. We know from the equator to 45 degree south is another 45 degrees. So if we add them up, we have a total of 135 degrees. 135 degrees times 60 nautical miles, because 1 degree is equal to 60 nautical miles, comes out to 8,100 nautical miles. So according to this, the sun at the equator is 8,100 nautical miles, or 9,321 statute miles, up in the sky. So now let's look at a little coincidence. The 8,100 miles, if you multiply that by the average moon length, comes out to 238,000 miles. If you take the 238,950 and multiply that by the 390 times distance, you also come out with 93 million miles. Interesting. Getting back to the triangle, here's one extra little tidbit. If you rotate the triangle and position the right corner to the North Pole as it states on the corner north, and the left corner is always pointing south, the sun now will point to the black line all the way around the map. And basically what it does is it tells us that the sun is coming from the east and that it's marking the hours of the Earth as the sun rotates. Now, let me ask you something. What does this look like to you?
"60 miles to the degree." 60 miles to the degree. It means each degree is in reality 60 nautical miles. The Gleason's map is scientifically and practically correct. In this video, I'm going to explain the sun based on the Gleason's map. As you know, the Gleason's map is scientifically and practically correct and was used in England, Canada, France, Denmark, Sweden, Germany and Australia. I hope this video will be very interesting for Marilyn's Spirit Level channel. She is a great flat earth activist. You can find the link to her channel in the descriptions below and some other great flat earth channels as well. The sun is one of the most important things in life and also one of the most important things on this map. Welcome to the flat earth. Unfortunately, I cannot say let's start with a common knowledge, so I'll say let's start analyzing the Gleason's map. At 12 o'clock noon, that is at the meridian of Greenwich, the zero longitude line, the sun rotates around the pole and completes its cycle within 24 hours. That's one day. According to the Gleason's map, the sun rotates around the pole. The time is written on the map, Greek numbers from 12, 1, 2, 3 o'clock, 4 o'clock until 12 o'clock night, and then from the morning back to 12 o'clock noon when it reaches the meridian of Greenwich the next day. The sun does not only rotate around the pole, but during the rotation it narrows its path to the Tropic of Cancer, then continue to rotate and widening its path to the Tropic of Capricorn. It means during the seasons the sun moves between the Tropic of Cancer and the Tropic of Capricorn. And on the 21st of December it reaches its peak, and on the 21st of June its peak on the Tropic of Cancer. The sun travels around the circle in 24 hours time. The circle is divided in 360 degrees. It means the sun travels 360 degrees in 24 hours time. That means the sun travels 15 degrees every hour. So this is 6 o'clock, 7 o'clock is 15 degrees, and then 8 o'clock is 15 degrees, another 15 degrees, 10 o'clock, and so on. Let's measure the latitude coordinates for the Tropic of Capricorn and the Tropic of Cancer. But before that, let's have a look at another wonderful feature of the Gleason's map. December solstice, the sun is on the Tropic of Capricorn. The 21st of December it reaches its maximum, and you can also see where the sun illuminates the area. Again, the Gleason's map is scientifically and practically correct, and it's written on the map. On December the 21st, the sun moves around the Tropic of Capricorn, and during the day lights up the southern portion of the Earth from the Arctic Circle to some portion of Antarctic ice. There is no sunlight, and sunlight is between quotation marks here, beyond 80 degrees south. but unknown region of ice. On the 23rd of December, the Sun commences his northward journey again, returning to his starting place and thus completes his season. June solstice. The Sun is on the Tropic of Cancer, and on 21st of June it reaches its maximum, and you can also see where the Sun illuminates the area. The Gleason's map is scientifically and practically correct. It's written on the map. In the figures June and December, the white represents the Sun's position in its respective month at noon. This shows sunlight inside the Arctic Circle for 24 hours. From June 21st, the Sun moves round the tropic in a spiral circle, widening every day until it reaches its destiny on the southern or outer solstice on December 21st. It's written on the map, the Sun moves. Scientifically and practically correct. Let's measure the Tropic of Capricorn. Can you see it? This is the 15th latitude line plus 5. It's 20 and then 21, 22, 23 and just a bit over the 23. So it's between 23 and 24. It's just over the 23 mark. And the Tropic of Cancer is also between 23 and 24. This is the 20, 21, 22, 23. As you can see, the 9 is 24, but sits between the 23 and the 24. I measured the Tropic of Capricorn between 23 and 24 degrees. Tropic of Cancer also between 23 and 24 degrees. So I had to search the internet and found it should be 23.5 degrees. Let's find out what the Gleason's map has to say. This is one of the most important things of the Gleason's map, the Sun, and is also one of the most important things a flat earther should know. The Sun is one of the most important things in life, and it's one of the most important things on this map. This is a zoom-in situation from the seasons, the sun, the solstices, and the key of some secrets. So let's get started. The Gleason's map is showing us that the sun rises from the east, and during the seasons it moves from the north and the south, between the north and the south, between the Tropic of Cancer and the Tropic of Capricorn. This is the equator, the middle. The equator, Tropic of Cancer and the Tropic of Capricorn. And this is the equator. If the sun rises from the east and moves during the season between the south and the north pole, why is the north pole on the right? Because if the sun rotates around the pole and I can see the sun rises from the east, that means the north should be on my left hand side and the right south. But on the Gleason's map, the north is on the right hand side. This is one of the greatest secrets of the Gleason's map, and I'll explain it in the next video. The sun rises from the east and travels during the seasons between north and the south. That means between the Tropic of Capricorn and the Tropic of Cancer. The Sun travels 30 degrees to the tropic to the north and 30 degrees to the south. It means the Sun travels between 30 degrees north and south. This is the 15 degrees, 30 degrees, 45 degrees. I am not looking at the longitude lines. This is a triangle, and this is an inverted triangle. It's the same triangle, the zero. This distance, the size, the distance is the same. Let me do it like this. Maybe you can see it. This is 90 degrees. This is 90 degrees. And this is also 90 degrees. So it's the same triangle, same distance. This is 0 degrees, 15 degrees, 30, 45. It's an inverted triangle. So it's the same distance from the Sun. On the equator is 0, 15 degrees, 30 and 45. So the Sun travels 30 degrees until it reaches the summer or the winter solstice. The same on both sides. The center is the equator. So this is the equator. The Sun travels from between north and the south. This is a quick drawing from the Gleason's map. The Sun is at the equator. It's 0 degrees. That's why the equator is 0 degrees. And measured from the Sun is 15 degrees, 30 degrees, 45 degrees. The equator is 0. This is not a latitude line. I'm just showing you the degrees measured from the Sun. So if the Sun is at the equator, it's 0 degrees, 15 degrees, 30 degrees. So if the Sun travels during the seasons between the south and the north, it reaches the 30 degrees. If we're standing on the ground and look at the Sun, we say, well, it's 90 degrees. And on the 15 degrees, it's 75 degrees. And on 30, it's 60. That's why this is not a latitude. Not only that, the distance between 15 degrees and 30 degrees and 45 degrees is not the same. It means if the Sun is 15 degrees, if we measured the angle to the Sun, we measured 75 degrees. And when the Sun is 30 degrees, if we measure the angle, we measure 60 degrees. Because this is 90, we measure 60 degrees. But when the angle measured from the Sun is 45 degrees and we are at latitude 45, we also measure 45 degrees. That is why this is very important, the latitude 45. Because the equator is the 0 and the latitude 45 is the latitude 45. But the 15 and the 13 is not the latitude because the distance is not the same between 15 degrees, 30 degrees and 45 degrees. But the 0 is the same. The Sun is straight above our head, is 90 degrees. From the Sun it's 0 degrees. And when the Sun is 45 degrees, if we are on latitude 45, we also measured 45 degrees. So this is very important. Let me draw an equator and explain more on an equator line. Okay, this is the latitude. This is the latitude. This is the sun's degree, 15, 30, but on 45, the angle of the sun is the same as the latitude. So if the latitude is 45 and the 0, the equator, they divided it in 15 degrees, equal size degrees, and the 60, etc. So the third 15, 30 is not the same, but a 45 degree is also the angle of the sun. So at 45 degree, if we are on latitude 45 degree, if the sun is at the equator, we measure an angle of 45 degrees. This is very important. We know the importance of the 45 degrees. This is the latitude. The equator, 15, 30, 45. Equal size pieces. So this is the latitude. Equator is very important. 45 degrees is very important. And it's just divided between equal size pieces. The question is, where is the 23.5 degrees? The Gleason's map is telling us when we are at the equator, the sun is 30 degrees, we're looking at the sun, let's say this. This is also 30 degrees. If the sun drops on exactly the 45 degree line, we will look straight at the sun at an angle of 23.5 degrees. So this is the 23.5 degrees. It means if we are on a 45 degree latitude, we're looking direct straight to the sun as well. This is what the Gleason's map is telling us. Let's go back to our Gleason's map and I'll show you all the details. This is the equator. This is the 45 degrees latitude. Let's follow the 45 degrees latitude and see where it takes us. It brings us at the base of the triangle, the center, the equator, between the Tropic of Capricorn and the Tropic of Cancer, the 45 degrees latitude. If the sun is at the Tropic of Cancer or Capricorn, and you are at a 45 degrees latitude, you will see straight at the sun at an angle of 45 degrees. This is 45, this is also 45, from the 45 degrees when the sun is at the equator, and it tells you it is also 45 degrees. You're looking straight at the sun if you are on the 45 degrees latitude. This is also the 45 degrees latitude. It is the same as when the sun is at the equator. When the sun is at the equator on the 45 degrees latitude, is 15, 30, 45, also on the 45 degree latitude, you will look at the sun at an angle of 45 degrees. When you are at the equator and the sun is 30 degrees, that means on the Tropic of Cancer or Capricorn, you will look at the sun at an angle of 23.5 degrees. This is the 23.5 degrees. The Gleason's map is perfect. It's a masterpiece. It's a masterpiece. Scientifically and practically correct. I draw on my map just to show you, but you don't have to do that. You can use a piece of string, strong piece of string. I use dentifloss, and you can also measure the degree. If you stretch the string exactly to the center of the sun and the center of the small circle, it measures exactly 23.5 degrees. 23.5 degrees. Let me zoom in, see if you can look at it as well. Let's go back to our drawing board and I'll show you exactly how it is mathematically. I made a quick, beautiful drawing. This is the sun. This is the equator, the 45 degrees. The sun, when the sun is at the equator, the angle is 45 degrees, looking straight at the sun. When the sun moves to the 30 degrees, Tropic of Cancer or Capricorn, it will reach to 45 degrees and you're still looking straight at the sun, like the Gleason's map showed us. And if you measure this angle, it will measure 23.5 degrees. This is a beautiful example. An A4 piece of paper, folded and makes a perfect square. This is a perfect square. It's a square. Measure the 30 degree line. This is the 45 degree line, where the 30 degrees crosses the 45 degrees, exactly at that spot. If you measure the angle, it will measure 23.5 degrees from the equator. This is my beautiful sun. And the beauty of it, exactly on the same spot. Now we know the importance of the equator, the importance of the 45 degrees latitude, the importance of the 45 degrees, the importance of the sun, the importance of the pyramid. Do you see what I see? Do you see it? Perfect triangle, equator, latitude 45, the base is flat and level. One thing is sure, everything is measured from a flat plane. The triangle and the sun. It's flat. The base is flat and level, scientifically and practically correct. 1 degree is in reality 60 nautical miles. The 0 degree angle measured from the sun is the 0 degree at the equator. The 45 degrees measured from the sun is the same as the 45 degrees measured at the latitude 45 degrees. It means if we know the distance from the equator to the 45 degrees latitude, then we know the distance from the base to the top. It's written on the map, 60 miles to the degree. It means 1 degree is in reality 60 nautical miles. 45 degrees times 60 nautical miles. Scientifically and practically correct. Thanks for watching, and I'll finish this video with some beautiful observations.
In this part of the video, I'm going to explain one of the most important things of the Gleason's map, especially for those who have a Gleason's map. And for my favorite friends, the globe or the flat earth deniers or globe believers, this is clearly a flat earth map. And as you can see, back in those days, I'm talking about 1892, so beginning of the 19th century, it was well known to be a flat earth map, and it was the new standard map of the world, so they knew about this. At the end of this video, you will also understand where they came with the number 23.4 degrees for the tilt of the earth, your spinning globe, if you believe in the spinning globe. It has everything to do with this. So it's going to be a little boring, but it's very interesting, especially for those who have the map.
Long time ago, they realized the sun moves to the north during the summer season and it moves back to the south during the winter season. So they pinpoint the exact location to the north, same as the south, and the center. The center is exactly 90 degrees and they call it the equator, and the other two locations are 45 degrees to the sun when the sun is at the center of the two locations. The 45 degrees is very important because it is the angle to the sun and it is the same as the latitude. So the 45 degrees is the latitude and it is the real angle to the sun. The rest are divided into equal sizes or degrees. Only the 45 degrees and the 90 degrees, that's when you're at the equator, are the real angles to the sun. The rest are just divided between the 45 degrees and the equator, or the 45 degrees and the vertical or the y-axis. Let's go back to the Gleason's map and have a look at this.
The Gleason's map is showing us when the sun is at the equator and you're looking straight at the sun, the angle is 0 degrees, or the angle between the sun and the latitudes or the base, this angle is exactly 90 degrees. 90 degrees, this angle. And when the sun moves to the north or when it moves to the south, it reaches the 45 degrees latitude lines. This is the 45 degrees latitude line. That's the one. Let me zoom in so you can have a better look. See the 45 degrees. This is the 45. So the sun reaches the 45 degrees latitude line. But when the sun is at the equator and you are on the 45 degrees, the angle is 45 degrees. The angle you're looking at the sun is 45 degrees. The angle between the sun and the base is 45 degrees. Let me illustrate this a different way. Follow me. When you are at the equator and the sun is at the equator, it is 90 degrees. You're looking 90 degrees at the sun. The angle to the sun is 90 degrees. When the sun is at the equator and you are at the latitude 45 degrees or 45 degrees south, you're looking at an angle of 45 degrees at the sun. And when you are at the 45 degrees north, you also look at the angle of 45 degrees at the sun. This is the same illustration as a drawing. At the equator, you're looking straight at the sun. The Gleason's map is very accurate, and I've noticed something very interesting. This one. Let me zoom in. That's the spot. So I decided to check how many degrees it is and to figure out what it means. This is 15 degrees, 30 degrees, 35, 36, 37 and a half degrees. And I asked myself, is it the 37 and a half, the degrees the sun moves, or is it the angle to the sun when I'm at the equator? I'm looking straight at the sun from the equator. So let's go back to the drawing board and have a look at it. The question is, the 37 and a half degrees, is it a number on the y-axis or is it the real angle to the sun? I draw both of them for you. The first one, the yellow line, is just a number on the y-axis. It's 37 and a half degrees. It crosses this line and you can project it at 24 and a half degrees on the latitude line. The second one is the green one. The green one is the actual angle to the sun. So the sun should be on this one or on the other one, on this one. This is 37 and a half degrees. The green line is the actual 37 and a half degrees if you're at the equator looking at the sun. You can project it on the latitude at 25 and a half degrees. This is the Tropic of Capricorn or the Tropic of Cancer. If the sun moves to the north, it's called the Tropic of Cancer. If the sun moves to the south, it's the Tropic of Capricorn. It depends if it's moved to the north or south, it depends. The northern side is, if the sun moves to the south, it's called the Tropic of Capricorn. If the sun moves to the north, it's called the Tropic of Cancer. This is the Tropic of Capricorn or the Tropic of Cancer. Let's have a look at the Gleason's map and see if we can confirm this number. This is 37 and a half degrees, so it should correspond with the latitude 25.5 degrees, because like we saw on our drawing, 37.5 degrees is exactly 25.5 degrees on the latitude.
First, let's verify if the distances between the tropics and the equator are the same. Tiny difference there. The Tropic of Cancer is 15, 20, 21, 2, 3, 4 is 24 degrees. And the Tropic of Capricorn, it's 15, 20, 21, 2, 3, between 23 and 24 degrees. There's a little distortion there. Probably caused by the printing and copying process, but this map is pretty accurate. My next question, what is the 23.4 degrees Earth tilt? Let's have a look at it and we'll get back to these numbers. The Gleason's map shows us that the sun moves between the 45 degrees latitude lines. And the Gleason deniers are telling us that the Earth tilts to the sun and back. Okay, again, the Earth tilts with 23.4 degrees closer to the sun, but in this case the sun is a million miles away. Let's calculate this distance and project it on the latitude line. I just want to show you, if you do a quick calculation, you can find this distance is the same as this one. So it crosses, this is the exact distance at the 25.5 degrees. So it's probably the 37.5 degrees is the correct angle, and it should end at the 25.5 degrees. Let's erase this because we have nothing to do with the globe. If I measure the same angle on the Gleason's map, it measures 36.5 degrees. It should be 37.5 degrees because that's the angle when the sun is at the 45 degrees latitude. So it should be 37.5 degrees. I looked again at the Gleason's map and realized the trajectory of the sun is like a circle. So then I asked myself, where is the center of this circle? Because if it's a circle, it's perfect. Everything works in a circle. Everything. Pi, golden mean, Fibonacci, everything. If it's in a circle, it is perfect. It works. So if the sun is part of the circle, there should be a center. This is a unique pyramid within a circle. And this is the center of the sun's path. And this is the trajectory of the sun. If you measure it, you will realize the sun reaches its minimum altitude at 33 degrees on the y-axis. What a coincidence. It's a very familiar secret society number, but it makes sense. If you calculate the angle of the 33 degrees line, the orange one, you will get 36.5 degrees. And that one corresponds with 26 degrees on the latitude. Yes, it makes sense. The Gleason's map shows us a lot of similarities with
well-known signs and symbols. This is the pyramid, the 45 degrees latitudes with an angle of 45 degrees. This is the sun on top of the pyramid. It's a unique pyramid. It fits perfectly in a circle. The trajectory of the sun is like this. It reaches the 33 degrees on a y-axis between the 45 degrees latitude lines. This is 33 degrees, which also explains, well, not explains, but similarities with the Freemason number 33, the highest degree, the 33 degrees of the Freemasonry, with a lot of similarities with the eye on the same level, this spot. And the same trajectory of the sun. You can also draw an eye out of it. A lot of similarities. And if you draw a line to project it on the latitude, the solstice, it will be like this. 33 on both sides, which are also a lot of similarities with the ruler you see. And the only thing left is, of course, so a lot of similarities with the well-known signs and symbols. Yes, a lot of similarities. The 45 degrees on both sides. It's a 45-degree pyramid. The center, equator, sun on top. The base of the pyramid is flat and level. Of course, sea level, water is level. It all makes sense. A lot of similarities with the well-known signs and symbols. And of course, you can't miss the circle compass. You can't miss it. It all makes sense. And for some of us, it never will.
Did Gleason made a copy of the globe? Maybe he did, but I don't see a curvature between the 45 degrees latitude line on his map. It's clear a curvature between equator and the 45 degrees latitude. On Gleason's map, between the 45 degrees latitude and the equator, it's flat and level, the base of the pyramid. Now you know where this symbol came from. Flat, level, plane. The sun is the most important thing. This is the triangle. Everything can be measured by using the triangle. The base of the triangle is flat and level between the 45 degrees latitude lines. The sun is one of the most important things in our life. One circle.